Hello, we are Team 5. We will start presentation about Burj Khalifa. We will gonna talk about role of team members, weekly plan, summary, day 3, challenges of process, preview of issues. This is a lot of team members. Lee Jinung, Choi-Jun take a role of day 3 and issues research. Shin Yong-taek, Ho Sung-won take a role of challenges of process research. Chang Min-ji take a role of making PPT and challenges of process research. Byun Sang-guk take a role of challenges of process research and presenter. In last week, we told the 3-day process about day 1 and day 2. Today, we will present day 3 and problems when constructing. This is a summary slide. Last week, we presented the background of the 3-day cycle and the construction method of the day 1 and day 2. When constructing high-rise building, they need a lot of manpower and equipment, so they need lots of cost per day. Projects should be completed in a short period of time, so new process of construction method needed. As a solution, Samsung C&T's 3-day process was used. 3-day process is to construct one floor per 3 days. In day 1, rubber prefabrication on the ground. Day 2, connecting rubber made in day 1 and installing molding using auto-climbing system. Today, we will present the final course of day 3. In the existing high-rise buildings, they use the winch transportation method, which is a method of raising the container containing concrete to the middle floor and then using the pump to send it back to the site. This technology was stable, but it took a long time. Burj Khalifa had to shorten the construction period time due to the problems with labor and labor cost, and adopt particular concrete pumping technology that could meet these conditions. The particular concrete pumping technology used in Burj Khalifa is a technique that directly pushes concrete by connecting pipes to the high-rise areas. The direct delivery of concrete had the disadvantage of not being able to shoot it up to the height of high-rise buildings, but the use of cutting-edge technology and special concrete in Burj Khalifa was able to raise it up a high level, which had a significant impact on shortening the construction period. Then, let's see why concrete pumping technology can shorten the construction period. This technology was more direct and constant than other technologies, enabling prediction and minimization of the time of the construction. And we can deliver concrete to the required location, minimizing the delay. Concrete pumping allows minimal labor to be used to carry out the entire process of the concrete placement. From this slide, we will talk about challenges of day 3. First of all, the problems that occur in the case of conventional concrete are as follows. First, temperature. Second, early strength. Third, workability. Construction is very difficult due to the environmental effects such as the temperatures of the desert, where the Burj Khalifa is located. In addition, early strength is very essential to build one floor every 3 days. But early strength could involve heat of hydration. High heat of hydration makes cracks, which is fatal to buildings. And in the case of general high-strength concrete, it is difficult to pump it high through piping because of its high viscosity. In addition, mixing it, considering workability to send it up to high place, is very low strength and the risk of segregation. So, considering process of making concrete and construction, there are many things to consider. For example, strength, workability, dry shrinkage, cracks, early strength, segregation, and heat of hydration. Let me tell you how these problems were solved, one by one. First, early strength. The concrete used in Burj Khalifa must be dried quickly. It must be dried within 10 to 12 hours. Then, the automatic lifting device can be activated. However, as we mentioned previous slides, for early strength to be fully exerted, the heat of hydration may increase. Also, the construction site has a very hot climate due to the geographical environment located in desert. That's why thermal management is necessary. To solve these problems, ice flake were mixed together when mixing concrete, and concrete pouring was carried out at night. Also, they used fly ash, which is a mixture to control the heat of hydration. Second, workability. Workability is considered to be the most important element of the concrete material properties used in this technique, as concrete is moving up higher floor using a pump and then pouring down. The workability can be controlled by water to cement ratio. If the water to cement ratio is high, workability is better than before, but the strength is lower than before. To overcome these problems, they get high workability and high strength by adding superplasticizers and silica fume. Also, the size of aggregate that makes up the concrete was controlled to get appropriate workability. In highlights, which requires high workability, use smaller aggregates to increase workability. And there is another problem about pipeline clogging. Concrete pipelines are frequently clogged when pouring concrete, which causes disruption in overall construction process, reduces the lifespan of the pipe, resulting significant cost loss. To prevent clogging, concrete in quantity needed was poured with constant rate. Despite this, a high-pressure washing machine was prepared next to the pipeline in preparation for clogging. Pumped concrete is delivered, and segregation occurs due to density difference. The higher the transport, the more time the segregation takes to occur, the more greater the segregation. The result is low-strength concrete than the expected strength. As a solution to segregation, the tower crane raised the concrete to repumping zone, located at 525 meters, and sent it to reduce the time of segregation. This method is a combination of the existing method, the winch transportation, and the concrete extrusion method, which reduced the segregation. To secure building stability and safety, many concrete testings were conducted. For example, mechanical properties, compressive strength, modulus of elasticity, durability test, permeability test, absorption test, creep, and shrinkage test. Also, other tests were conducted, for example, mock-up test and pump simulation test. These are under the same conditions, as the actual structure were carried out to ensure safe construction. So, you may know the construction method of day 3 and details about used concrete, construction problems about concrete, and solution. After concrete strength is exerted, one floor is constructed, and the day 1 process is repeated again. This is 3-day process cycle. In addition to 3-day process, there are other problems in the construction process to pay attention. So, we will briefly tell you the problems to be dealt with in the future, such as the resistance method of various basic loads and the facility to be installed inside the building. There are many interesting issues in Burj Khalifa. Total materials weight of about 540,000 tons were used. Its weight same as 100,000 elephants. Burj Khalifa had to have a special structure in order to resist a huge amount of axial force, to minimize weight and maximize floor area. Also, there are other issues about lateral force from wind load and earthquake. First, wind load. The higher the height, the greater the load is inflicted on the building. Second, earthquake. Dubai has had about 7 earthquakes in the past year. So, Burj Khalifa comes up with a unique way to resist this load. Next, we will talk about issues of a facility for occupations. The Burj Khalifa took the idea of elevators to its extreme, as it accommodates over 35,000 people. Now, the final technological leap of the world's biggest building is to keep its occupants safe. It was difficult to evacuate all the occupants to the first floor, so there are refuge rooms to be safe. By securing stability, they can get safety. Next week, we will learn about the most page problems, how to resist the actual forces, and the unique structure system, buttress core. This slide is our last slide. Thank you for listening.